In this set of videos, we're going to be taking a look at the answers to the forces problems with mu, the coefficient of friction. In number one, the object below is sliding to the right with a velocity of 10 meters per second. Given that the coefficient of friction between the object and the ground is 0.34, we want to find out what the acceleration of that object is. So, drawing the picture, I've got the normal force going up on the object, the force of gravity pulling down, friction goes to the left. I know it's moving to the right, but there's no force pushing it, and there's no velocity force or anything, so there's nothing going to the right. It just is as it is. Numbers that we're given, we know the mass is 5 kilograms, we know the coefficient of friction mu is 0.34, and we are trying to find acceleration. Now, when we set up our equation, we're going to have the friction going to the left equals ma, but we don't know what friction is. We know what the coefficient of friction is. And in order to use the coefficient of friction to find the actual force, we need the normal force, because friction is equal to the coefficient times the normal force. So that's why the first thing that I typically do in these problems is find the normal force. So the normal force is upward, force of gravity is downward, and it is not accelerating up and down, which means that the normal force up equals force of gravity down. And we know force of gravity is 5, because that's the mass, kilograms, times 9.8 meters per second squared, which gives me a normal force of 49 newtons. Now, some people might like to then just solve for force of friction by saying, okay, friction equals the coefficient, the 0.34, times the normal force, 49, and then have a number for friction, and then moving into solving for A. If you want to do that, that's perfectly fine. I actually just do it in problem, so you'll see what I'm talking about as we go through. So as we said earlier, friction, negative friction, because it's going to the left, equals ma. Well, friction is the coefficient of friction times the normal force. We have the coefficient of friction, it's 0.34. We have the normal force, we just solved for it, which is 49 newtons, and we're trying to solve for A. So let's just divide the mass over to the left, which is why it's in the denominator now. And now we can just plug in our numbers. The coefficient, 0.34, the normal force 49, and m is 5 kilograms. All that equals A, and when we plug in our numbers into our calculator, we get negative 3.3 meters per second squared for acceleration. Now we're going to move on and take a look at problem 2. Problem 2, you are pushing the object below to the right with a force of 20 newtons. The coefficient of friction between the box and the ground is 0.2. Now we're finding the acceleration of this situation. So in number 2, we have a normal force going up, we have a force of gravity going down, the force of push goes to the right, and the force of friction goes to the left. Numbers that were given in the problem, the force of push is 20 newtons, the coefficient of friction is 0.2, and the acceleration is my question mark. Just like before, we want that normal force so that we can find the force of friction. Now the normal force is equal to the force of gravity because, again, normal's up, gravity's down, and there's no acceleration in the y up and down direction. So the normal force equals the mass, 9 kilograms, times g, which is 9.8 meters per second squared, and that's going to give us a normal force of 88.2 newtons. Now let's go and solve for the acceleration. I know my force of push is to the right, so it's going to be positive in my equation. Force of friction is to the left, so that's minus force of friction, and all that's going to equal m times a. Now where I had force of friction, I'm just going to plug in what force of friction is, which is the coefficient times the normal force. That's the equation for friction. All I said is friction is coefficient times normal force, so I plug that into my equation. Now we're trying to solve for acceleration, so I'm going to divide by the mass, which is why it ends up in the denominator on my left side. Now I can plug in my numbers. I know the force of push, 20 newtons, the coefficient of friction was 0.2, the normal force we solved was 88.2 newtons, and the mass in the bottom is 9 kilograms. All of that's going to equal the acceleration. So when I plug that into my calculator, I get 0.26 meters per second squared for acceleration.